Here we have O-Level 2021, Additional Math Paper 1. Let's check out question number 1, which is a search question. In this question, we have a rectangle. Let me do a quick sketch of this rectangle. So this, let's say it is a rectangle. According to the question, the length, so this, let's say it is the length. The length, I'm going to call it L. The length is 3 plus 2 square root of 3. And the area, so here, let's say this is area. I'm going to call it A. The question says that the area is 6 plus 5 square root of 3. We are supposed to find the width. So let's say this is the width, and I'm going to call it W. And according to the question, we are supposed to change this width into the form of A plus B square root of 3. So for the area of a rectangle, it is going to be equal to length multiplied by width, which means that the width is going to be equal to area divided by length. The area is 6 plus 5 square root of 3, and the length is this thing here, so it is 3 plus 2 square root of 3. We are supposed to re-express this to make it look like this form, so we are going to try to rationalize this. In the denominator, we will multiply this by 3 minus 2 square root of 3. For the numerator, let's multiply it by the same thing, 3 minus 2 square root of 3. For the denominator, we have a form of A plus B multiplied by A minus B. So for the denominator, it is going to be A squared minus B squared. So it is going to be 3 squared minus 2 square root of 3 squared. For the numerator, let's just expand it. So this multiplied by this, 6 multiplied by 3 gives me an 18. This multiplied by this is going to be minus 12 square root of 3. This multiplied by this plus 15 square root of 3. This multiplied by this is going to be equal to minus 10. And we have a square root of 3 multiplied by square root of 3. So we have a 3 here. For the denominator, it is going to be equal to 3 squared, it is going to be equal to 9. Minus away, this will be 2 squared, which is 4, square root of 3 squared, which is going to be equal to 3. So we have a 4 multiplied by 3, 9 minus 12. So this, if I were to simplify the numerator, we will be getting a minus 12 plus 3 square root of 3. So we are getting a minus 12 plus 3 square root of 3 divided by the denominator, which is minus 3. So this divided by this, negative 12 divided by negative 3, this is going to be equal to positive 4. This divided by this is going to be negative square root of 3. So this is my answer for question number 1. Let's take a look at question number 2. So now in question number 2, according to the question, we have two graphs. One is a curve. Let me write it down. The equation of the curve is given to us as xy plus 10 is equal to 0. And we have a line. The equation of the line is x plus 2y plus 1. This is equal to 0. And they're going to be intersecting at 2 points, P and Q. We are supposed to find the x-coordinate of the 2 points, P and Q. So to do that, we are going to solve this as a pair of simultaneous equation. I am going to call this as equation number 1. As for this, let me manipulate this to make x the subject. So x is going to be equal to minus 2y minus 1. This will be equation number 2. And I'm going to substitute equation number 2 into equation number 1. So let me write it down. I'm going to substitute equation number 2 into equation number 1, which will then give me x is going to be replaced by minus 2y minus 1. Then after that, multiply by y plus 10. This is equal to 0. Let's expand this. And expanding this, we are going to be getting a minus 2y squared minus y plus 10. This is equal to 0. We can factorize this. Factorizing this gives us a 2y plus 5 multiplied by minus y plus 2. This is equal to 0. Which means that y is going to be equal to minus 5 over 2, or based on this, y is going to be equal to 2. But the question is asking us for the x-coordinate of P and of Q. So based on this y and this y, we are going to resubstitute it back into equation number 2 to get a corresponding x-coordinate. So when y is equal to minus 5 over 2, let me write it down. When y is this minus 5 over 2, x is going to be equal to minus 2 multiply by minus 5 over 2 minus 1. This is going to be equal to 4. So this is one of the x coordinates. And the other one will be when y is equal to 2. So the x coordinate of the other point is going to be equal to minus 2 times 2 minus 1. This is equal to minus 5. So these are the two answers. Let's move on. Let's take a look at question number 3. Okay, now in question number 3, we are given the expression 3 minus 12x minus 2x squared. We are supposed to re-express it into the form, which is the completed square form. So let's try to do a completing square to this. Okay, the first thing that we need to do is to make sure that the coefficient of x squared is positive 1. So I'm going to factorize out minus 2, which will then give me this as x squared. Factorizing out minus 2 from here gives me a plus 6x. And factorizing out minus 2 from here gives me a minus 3 over 2. Let me just do a quick check. Minus 2 multiplied by this gives me a positive 3. So this is still correct. So this is going to be equal to minus 2 completing square to this. It is going to be x plus 3 square minus 3 square minus away this, which is minus 3 over 2. So we have a minus 2 of this. This is x plus 3 square. This, minus 9 minus 3 over 2 is going to be minus 21 over 2. So multiplying this in, we will have a minus 2x plus 3 square. This times this. This is going to give me a positive 21. So now we have the form that the question is asking us for, and hence the question says we are supposed to state the coordinates of the turning point of the graph of y is equal to this. It is a turning point. In fact, we do know that it is a maximum point because this is going to give us a parabola with a set face since the coefficient of x squared is negative. But regardless, we just need to quote that it is a turning point. So for the turning point, let's try to state the coordinates. So the turning point is going to be at the x coordinate is going to be the x that caused this to be equal to 0. So for x to cause this to be equal to 0, x is going to be equal to minus 3. And the y coordinate will be when x is equal to minus 3. So this whole thing will become 0. If y is going to be equal to this, then y will just be equal to 0 plus 21. So y is going to be equal to 21. This is the turning point. Let's move on. Let's take a look at question number 4. So here in question number 4, we are supposed to do an integration. Question number 4, we are supposed to be integrating this 3 over x squared plus 4 over 3x minus 5. So to integrate this, let's try to do a bit of manipulation to this. So I'm going to rewrite this as 3x to the power of minus 2. Plus this, I can let it remain. So 4 over 3x minus 5. So integrating this, it is going to be x to the power of minus 2 plus 1, which is minus 1 divided by minus 1. Plus integrating this, we have a 4, which is the coefficient. I'm going to just let it be. So 1 over 3x minus 5. When we integrate it, it is going to be equal to ln 3x minus 5 divided by the coefficient of x, which is 3. And let's not forget about the plus c. So we have this. Let's do a bit of simplification. This will give us a minus 3 over x plus 4 over 3 of ln of 3x minus 5, then plus c. Okay, so far so good. Let's take a look at the next question, which is question number 5. It is a partial fraction question. Yep, partial fraction. So in question number 5, we have this 13x minus 6 over x squared, then 2x minus 3. We are supposed to express this in the form of its partial fraction. So we are going to let this be equal to, based on x squared here, we're going to let this be equal to a over x plus b over x squared. And then based on 2x minus 3, we're going to rewrite it as c over 2x. So here, let me just rewrite this over 2x minus 3. So we're going to try to solve for a, b, c. I'm going to multiply this equation here throughout by this x squared multiplied by 2x minus 3. So this, when I multiply it by the denominator, I'm going to be getting a 3x minus 6 is equal to this multiplied by this will give me an ax 2x minus 3. This multiplied by this will give me a b x squared, and x squared can be cancelled. So it will be multiplied by 2x minus 3 plus c times of this multiplied by this. This 2x minus 3 and 2x minus 3 can be cancelled. So cx squared. Let's try to solve for a, b, c by substituting convenient values of x into this equation over here. For example, if I were to let x be equal to, let's try. If I were to let x be equal to, say, 0, if I were to let x be equal to 0, this will disappear because this is an x, and this will also disappear. So I will be able to solve for b directly. I think this is a good number to go for. So letting x be equal to 0, on the left-hand side, we will have a 0 minus 6. So it's going to be just minus 6 is equal to, this will become 0 plus b times of 2 times 0 is going to be 0. So I will be left with a minus 3 plus this is also going to be equal to 0. This gives us the value of b, and this value of b is going to be equal to minus 6 divided by minus 3 is going to be equal to 2. Is there any more convenient values that maybe we can try to substitute into this equation so that I can get either a or c quickly? I think so. It is going to be the value of x that caused this to become 0. Because if this becomes 0, which is when x is equal to 3 over 2, this will also become 0. We will be able to get c directly. So the next one I'm going to go for is when x is equal to 3 over 2. So on the left-hand side here, it's going to be 13 multiplied by 3 over 2 minus 6 is equal to, when x is equal to 3 over 2, this becomes 0. So here we have 0. This will also become 0, then it will be c multiplied by x squared, which is going to be 3 over 2 squared. This will give us the value of c. c is going to be equal to 6. Okay, now I don't think we have nice value that, that we have just quoted here and here, which will cause some of the terms here to totally disappear. But I do have numbers that are easy to substitute, right? For example, when x is equal to positive 1. So let's try that. If I were to let x be equal to positive 1, then we will have a 13 multiplied by 1 minus 6 is equal to a, which I have yet to solve. I'm going to write it down. A multiplied by 1, then 2 minus 3, plus b is 2. So we have a 2 of x is equal to 1. So we have a 2 minus 3, plus c is 6. Multiplied by x is equal to 1, so 1 squared. So here I will be able to solve for a directly. Making a the subject, this will give me the value of a to be equal to minus 3. Nice, because now we have a, b, and c. Therefore, I can re-express this into its partial fractions. This divided by x squared, 2x minus 3. This is going to be equal to a. A is equal to minus 3. So minus 3 over x plus b is equal to 2. So plus 2 over x squared. And c is equal to 6. So it's going to be plus 6 over 2x minus 3. Okay, let's move on. Let's take a look at question number 6. Question number 6. Question number 6, it is a polynomial question, and we have this polynomial p that is given to us. I'm going to let this polynomial be px. So px is equal to 2x to the power of 3 minus x squared minus 13x plus k. And in part A, we are supposed to solve for k when we are given that this polynomial is going to leave a remainder of 6 when it is divided by x minus 2. So we're going to make use of the remainder theorem. The remainder theorem tells us that p, when it is divided by x minus 2. So p2, this is going to give us a remainder 6. So p2 is going to be equal to 2 times 2 to the power of 3 minus away, x is going to be replaced by 2. 2 squared minus 13 times 2 plus k, this is equal to 6. This will help us to solve for k. K is going to be equal to 20. Next, in B, now we are given the value of k. K is equal to minus 6. So px is going to be equal to 2x to the power of 3 minus away x squared minus 13x. K is given to us as minus 6, so we have this. According to the question, it has a quadratic factor. This factor is 2x squared plus ax minus 3. This is x to the power of 3, so if we have a quadratic factor, we will be expecting another possible factor, which is going to be a linear factor. So let me rewrite this, okay? Based on the quadratic factor that is given, I am going to let this px here, 2x to the power 3 minus x squared minus 13x minus 6, be equal to the quadratic factor, which is given to us by the question, as 2x squared plus ax minus 3, multiplied by a linear factor. Okay, this is x to the power 3, this is x squared, so the one that I'm going to be multiplying this with has to be linear. I'm going to call this bx plus c. So quadratic factor multiplied by this is going to give me this. In fact, we can observe and get and state the values of b and c. For example, I can see that on the left-hand side here, this is 2x to the power of 3. And the only way for us to be getting a 2x to the power of 3 on the right-hand side is to take this, multiply by bx. This is the only way for me to get a x to the power of 3. So if this multiplied by this, which gives me x to the power of 3, will give me a 2x to the power of 3, that means b over here has to be equal to 1. Right? So 2x squared multiplied by x will give me 2x to the power of 3. Similarly, if you're to look at this minus 6, which is the term that is independent of x, can only be obtained if I were to take minus 3 multiplied by c. So this multiplied by this is going to give me a minus 6. From observation, we can then see that c over here has to be equal to a 2, because minus 3 multiplied by 2 gives me a minus 6. So now, in fact, we have only one unknown left in this equation, which is the a that I am supposed to solve. As for a, there are two ways that I can try to solve for a. I will either expand this, or we can be a bit more focused by just observing for the coefficient that is going to be involving a. For example, if I were to work on the coefficient of x squared, let me write it down. So if I were to work on just the coefficient of x squared, on the left-hand side, what is the coefficient of x squared? The coefficient of x squared is minus 1. And I've chosen x squared because I know that on the right-hand side, x squared will involve the number a. But how are we going to be getting an x squared on the right-hand side? We will be taking this x squared multiplied by this. This will give me x squared. So when this multiplied by this, it is going to give me a 2, oh no, it's not 2. This multiplied by this is going to give me a 4x squared. So the coefficient is 4. Is there any other x squared? Of course, that's why we chose x squared to involve a, because ax multiplied by x is going to give me a ax squared. So the coefficient of ax squared is going to be plus a. So minus 1, which is the coefficient of x squared, is going to be equal to the coefficient of x squared on the right-hand side is going to be equal to 4 and then plus a. So this tells me the value of a is going to be equal to minus 1 minus 4. A is equal to minus 5. This concludes for us question number 6. We can move on to question number 7. Now let's take a look at question number 7, and I've drawn the graph over here also. We are supposed to explain why c over here is equal to minus 3 in part A. And to do that, I'm going to first try to find the amplitude, which is this a over here. The amplitude is this length. So to get this length, I'm going to take this length divided by 2. And what is this length? I can take the y-coordinate of the maximum point minus away the y-coordinate of the minimum point, which is minus 8, divided by 2. So this gives me a 10 divided by 2 is 5. As for c, when I let x be equal to 0, this is going to become 0. So y is going to be equal to c, which means that the coordinates of this point is going to be 0, c. The y-coordinate of this point is c. How do we get the y-coordinate of this point? I'll take the y-coordinate of the maximum point minus away 5, which is the amplitude. So c is going to be equal to 2 minus 5, which gives us the y-coordinate of this point, which is c. This is equal to minus 3. B, we are supposed to find b. B is here, and this b is going to influence the period of this trigonometric graph. For the original graph of sine x, the period is 2 pi. So sine bx, the period is going to be equal to 2 pi divided by the coefficient of x, which is b. And if I were to observe this graph, what is the period? The period is pi over 2. So this is equal to pi over 2. This tells us that b is going to be equal to, if I were to cross multiply, b is going to be equal to 4. And the last part, part C, we are supposed to then state the equation of the curve. And we have already found out what is the values of A, B, and C. So the curve will be y is equal to A, which is 5. Then sine B, which is 4. X plus C, which is minus 3. So we have this for part C. Let's take a look at the next question, question number 8. Let's take a look at question number 8. So we have this field over here, and we are supposed to find the area of the triangle plot BPQ. So BPQ, that's supposed to find the area of this, and this area is A. And my plan to find A is to take the area of the entire rectangle, minus away the area of this triangle, and this triangle. So the area A is going to be the area of the entire rectangle, which is going to be equal to base times height. So 50 multiplied by 80, minus away the area of this triangle. So it's going to be half times base times height, minus away the area of this triangle, which is also going to be half times base times height. So it's going to be equal to half times base 50 multiplied by this CQ. But we don't have CQ yet, but it is very easy for us to derive CQ. What is CQ? CQ is going to be 80 minus away 2x. So this is going to be CQ. So this is here 80 minus away 2x. Then I'll minus away this triangle. This triangle is going to be half times 2x multiplied by this dp. And let's derive dp. dp is going to be equal to 50 minus away this length here. So it's going to be 50 minus x. So here is going to be equal to 50 minus x. So this is going to be equal to 4,000 minus away this is going to be 40x. Expanding this, we will have a minus 2,000 plus 50x. Expanding this, we will have a minus 50x plus x squared. So A is going to be equal to x squared minus 40x plus 2,000. And this is what the question wants us to show. This is part A. And part B, we are supposed to find the stationary value of A. So let's make use of differentiation. So A is equal to this. Let's find dA dx. dA dx is going to be equal to 2x minus 40. And to find the stationary value of A, we are going to let dA dx be equal to 0. So by letting dA dx be equal to 0, it is going for 2x minus 40 to be equal to 0. This tells me that x is going to be equal to 20. This will give me the stationary value of A. Let's try to quote it. So the stationary value of A is when x is equal to 20, that will be 20 squared. Subbing this back into here, minus away 40 multiplied by 20 plus 2,000. The stationary value of A is going to be equal to 1600. And we're supposed to determine the nature of this stationary point. So to do that, let's use the second derivative. So from here, let's try to find d square A dx square. d square A dx square is just simply going to be equal to 2, and this is bigger than 0. Therefore, we know the nature of this stationary point. A, since d square A dx square is going to be bigger than 0, A is at this stationary point, it is a minimum. Okay, this is question number 8. Let's move on to question number 9. Question number 9 is this. It is a coordinates geometry question. Now, question number 9, we are given a kite. And on this kite, we know that AB is equal to AD. This is given to us by the question. and BC is equal to CD. This is also given to us by the question. And in part A, we are supposed to come up with an equation that is going to involve H and K, which means that we are going to try to make use of the geometry that we see here to try to bring the point B and point D together, because this is where H and K lies. And one geometry that can help me to involve point B and point D is actually what the question has just told us, which is BC is equal to CD. This length BC is square root of x1 minus x2 square, so 0 minus 6 square, plus y1 minus y2 square, k minus 6 square. CD, again, I'm going to use the same formula to find the length of CD, which is going to be x1 minus x2 square, so 6 minus h square, plus y1 minus y2 square, which is going to be 6 minus 0 square. If I were to square both sides, the square root will disappear. As for this is going to be equal to minus 6 square is going to be 36. I'm going to leave this as it is, square. I'm going to also leave this as it is, plus 6 square, this is also going to be equal to 36. So 36 and 36 can be cancelled. I will be left with just k minus 6 square is equal to 6 minus h square. I'm going to bring all to the left-hand side, which will then give me a k minus 6 square minus away, this is going to be equal to a 6 minus h square is equal to 0. And the reason why I am doing this is because now we have a a square minus b square expression on the left-hand side, which will become a plus b, a minus b, correct? So if I were to do that, then it will be a plus b, which is k minus 6 plus 6 minus h, then multiply by a minus b, which is k minus 6 minus away 6 minus h. Then this is equal to 0. So for this, we are going to be getting a k minus h. As for this, we will be getting a k plus h minus 12. So this is equal to 0, which means that k minus h must be equal to 0, or k plus h minus 12, this must be equal to 0. This tells me that k is going to be equal to h, and this is not possible. Why? Because the question says so. The question says that k cannot be equal to h. Okay, so it is here, which means that the only other possibility is for this to happen. And when this happens, by bringing 12 over to the other side, we have a k plus h. This is equal to 12. So this is what the question wants us to show. Let's move on to part B. In part B, we are given the value of h now. H is given to us as 4. So this here, okay, now this here is equal to 4. And by making use of what we have in part A, so for h to be equal to 4, by making use of what we have in part A, which is h plus k is equal to 12, which means that 4 plus k, this is equal to 12. This tells us that k is equal to 8. So this now is going to be equal to 8. So with this that we have, we are supposed to find the coordinates of A. And I'm going to let this A here, since it's lying on the x-axis, so the y coordinate is 0. I'm going to let the coordinates of A here be A, 0. So I'm going to write it down here in my solution. I'll let coordinates of A be A0. And I'm going to make use of the geometry that is given to us by the question, which is AB is equal to AD, to try to solve for the x coordinate of A, which will then give us the coordinates of A. So AB, again, square root of. So for AB, I'm going to take these 2 points. So x1 minus x2 square plus y1 minus y2 square is going to be equal to square root of AD. AD is going to be square root of x1 minus x2 square again. So we have a minus 4 square plus y1 minus y2 square, which is 0 minus 0 square. So squaring both sides, the square root will disappear. I'm going to do the same thing as what we have done in part 1. And for this, I'm going to expand it. Okay, actually it is just going to be a square here. Then minus 8 squared, this is going to be equal to plus 64. It's going to be equal to, expanding this, is going to be a square minus 8 a plus 16. 0 squared is just going to be 0, just going to be 0. So a squared and a squared will disappear. We have a 64. This is going to be equal to minus 8a plus 16. This gives us 8a is going to be equal to minus 48, which tells us that a is going to be equal to minus 6. Therefore, we know that the coordinates of a, which is a0 is minus 6, 0. Let's move on to the last part when now we know that a here is equal to minus 6. Let's try to find the area of this kite in part C. So in part C, the area of the kite is going to be, okay, we are going to make use of the shoelace method, okay? So it's going to be half of, I am going to choose a point and to start. And that point that I'm going to choose to start, preferably it has as many 0 as possible. So this is a good point, this is a good point, and this is also a good point. Let me just start with here, okay? Then after that, we are going to go anti-clockwise. So if I were to start with this, it will be minus 6, 0. Anti-clockwise, the next point is going to be this, 4, 0. The next point is going to be 6, 6. And after that, it is going to be this, which is 0, 8. And I'm going to repeat the first point again, which is minus 6, 0. So this is going to be equal to half. So I'm going to take this direction, multiplying them and adding them together. This gives me a 72. Minus away this times this, plus this times this, plus this times this, plus this times this, minus 48. So the area is equal to 60. Okay, question number 10. Let's move on. Question number 10 is a trigonometric question. So question number 10, we are supposed to prove the identity that is given to us in part A. And to prove this identity, I'm going to start with the left-hand side. So the left-hand side of this identity is sine theta over 1 minus cosine theta minus 1 over sine theta. We will usually try to start from the side that looks a bit more complicated because it's usually easier to simplify than to make a simplified version, which is this cotangent theta, into the left-hand side. So I'm choosing the left-hand side to start off with, and I'm going to combine this into one single expression, one single fraction. So this will be sine theta multiplied by another sine theta minus away 1 minus cosine theta divided by sine theta 1 minus cosine theta. So we have a sine square theta here, minus away 1 plus cosine theta divided by, this is sine theta 1 minus cosine theta. I'm going to try to make the numerator to become in terms of just one variable, which is cosine theta, by re-expressing sine square to 1 minus cosine square. So we have this minus 1 plus cosine theta divided by, I forgot the bracket here, so divided by sine theta 1 minus cosine theta. So now we have, okay, 1 and 1 will disappear. So we have a cosine theta minus cosine square theta divided by, this is sine theta, then 1 minus cosine theta. We can factorize out cosine theta, which will then leave me with a 1 minus cosine theta in the numerator divided by sine theta, then 1 minus cosine theta in the denominator, and this can be cancelled. We are left with just a cosine theta over sine theta, and this is cotangent theta, which is the right hand side. So we have proven part A. We are going to make use of this to hence solve the second equation that is going to be given to us where theta is between 0 degrees and 180 degrees. So in part B, let me write down this equation, which is sine 2 theta divided by 1 minus cosine 2 theta minus 1 over sine 2 theta. This is equal to minus 2, where theta is going to be between 0 degrees and 180 degrees. So if I were to look at this, especially the left-hand side of this, and compare to part A, we can see that all the theta is replaced by 2 theta over here, which means that on the left-hand side here, we can actually rewrite it as cotangent of 2 theta based on what we have in part A. So this is equal to minus 2. And what is cotangent? Cotangent is 1 over tangent. right? So this, I can write it as 1 over tangent 2 theta. This is equal to minus 2, which tells us that we are working with actually just a tangent 2 theta is equal to minus 1 over 2. And there are two things that we need to do. First is we need the reference angle. So let me write it down. The reference angle is going to be equal to tangent inverse of minus 1 over 2, which is equal to 26.565 degrees. And this range that is given to us for theta is meant for theta, but we have a 2 theta here. So we need to find a new range for us to analyze 2 theta. So we're going to multiply this throughout by 2, which will then give me a 2 theta, which means that 2 theta is going to be between 0 multiplied by 2 is going to be still 0. And 180 degrees multiplied by 2 gives me 360 degrees. And tangent of this is equal to minus half. So if I were to go for add sugar to coffee, tangent is going to be positive here and here, which means that for this particular question, we'll be expecting the angle to be in the second quadrant or the fourth quadrant. So let us write it down. 2 theta, if you were to be in the second quadrant, then it is going to be 180 degrees minus away the reference angle, 26.565 degrees. Or if you were to be in the fourth quadrant, then it is going to be 360 degrees minus away the reference angle, which is 26.565 degrees. So based on this, we will be able to work out two values for theta, and they are 76.7 degrees, and the other one is 166.7 degrees. Question number 11. Prove in plane geometry question. So question number 11A, we are supposed to prove that the triangle ABC, this triangle here is an isosceles triangle. And the first thing that I'm going to do is to look at this angle here. Okay, this angle here is the same as this angle here by alternate segment theorem. Let me write it down. So angle TCA, this angle here, is equal to this angle here, which is angle ABC. And the reason is because we have an alternate segment theorem. And because this is parallel to this, so this angle here, which is angle TCA, is also going to be equal to this angle, right? And this is angle CAB. And this is because of alternate angles. Let me write it down. Alternate angles, and this is based on the fact that BA is parallel to CT. So this is equal to this is equal to this, which means that these two angles are the same. This angle and this angle, they are the same. So therefore, we can then say that angle ABC is equal to angle CAB. And this will form for us the base angle of this triangle. And since these two base angles are the same, we can then say that this triangle here is isosceles. So this implies that triangle ABC is an isosceles triangle. This is base angles of isosceles triangle. Okay, we have proven part A. Let's move on to part B. In part B, we are going to make use of some of the geometry that we have derived from the previous part, which is this angle here. This angle is the same as this angle, which is also the same as this angle. And I'm going to call this angle theta. So we have theta over here, we have theta over here, we have theta over here. Let me write it down in my solution. So I'm going to let angle ABC be equal to angle CAB, which is also angle TCA. I'm going to let this be equal to theta. And can you see that this angle here will also be theta, right? Because we are making use of alternate segment theorem. So this angle here is also going to be theta. So this angle here, which is angle TAC, will be equal to this angle, which is angle ABC. So this is also theta because of the alternate segment theorem. Okay, let me just go for TH. So alternate segment theorem. Okay, I think this is actually pretty obvious already because we know that this angle has to be equal to this angle, right? Because in this triangle, base angle, in this triangle, the two same base angle. So this must be equal to this. So that is how we're going to try to prove that angle BCA, which is this, BCA, is equal to angle CTA, which is this. But we need to write down something, right? So let me do it this way. Let me focus on this triangle, okay, and make use of the sum of all the angles in a triangle, which is angle ABC, angle ABC theta, plus angle CAB, which is this angle, plus angle BCA. This is going to be equal to 180 degrees. And what is this? This is theta plus angle BCA. This is equal to 180 degrees. This tells us that we have a 2 theta plus angle BCA. This is equal to 180 degrees. That is when I base it on this triangle. And I'm going to do the same for this triangle here. So for this triangle, it is angle TAC. So this angle plus angle TCA. So this angle plus angle CTA, which is this angle. This is equal to 180 degrees. This is theta plus this is also theta plus angle CTA. This is equal to 180 degrees. So we have a 2 theta plus this CTA. This is equal to 180 degrees. Therefore, we can say that this angle, angle BCA, is equal to this angle, angle CTA. Okay, this is what the question wants us to prove in part B. We can move on. Let's take a look at question number 12. Question number 12 here, it is this question that is going to be testing us on exponential. It is going to be testing us on logarithmic. Let's take a look. So in this question number 12, part A, we are given that 6 to the power of x is equal to 5 times 3 to the power of x plus 1. We're actually supposed to solve for x, and x is supposed to be equal to log of 15 divided by log of 2. So let's try to manipulate this that we have here. Okay, this is going to be 6 to the power x. I'm going to let it be. This is going to be 5. I'm going to break this up into 3 to the power x multiplied by 3 to the power of 1. So that I can divide this across to the other side, which will give me 6 to the power of x divided by 3 to the power of x is going to be equal to 5 times 3. This is equal to 15. And I can actually combine these together because they have the same index. So it's going to be 6 over 3, the whole thing to the power of x. This is equal to 15, which is 2 to the power of x. This is equal to 15. I'm going to apply log on both sides. So log 2 to the power x, this is equal to log 15. This x, if I were to bring it forward, it will be x log 2 is equal to log 15. And this is what the question wants us to show. Log x is going to be equal to log 15 over log 2. So this is for part A. Let's take a look at part B. Part B, we have this equation, log to the base 3x plus log to the base 9 of x plus 2. This is equal to 2. We are supposed to express this into a cubic equation in x. Okay, we are not even needed to solve this. We just need a cubic equation that is in terms of x. So let's try by going for the same base, and I think 3 is going to be a good number for the same base. So this, I'm going to let it be 3x plus this, I'm going to do a change of base, log to the base 3 of x plus 2 divided by log to the base 3 of 9 is equal to 2. And what is 9? 9 is 3 squared. So I can rewrite this further, log to the base 3x plus this is log to the base 3 of x plus 2 divided by 2. If I were to bring it forward, it will be 2 log to the base 3. And what is log to the base 3? 1. So this will sort of like disappear. This is going to be equal to 2. I'm going to multiply this throughout by 2, which will give me a 2 log to the base 3 of x. Since this denominator is just going to be 2 times 1, multiplying it by 2, 2 will disappear. So we have a log to the base 3 of x plus 2. This is 2 times 2, so this is going to be equal to 4. And 2, I'm going to bring it up, okay? So it will be log to the base 3 of x squared plus log to the base 3 of x plus 2. This, I am going to rewrite it as 4 log to the base 3 of 3, which I can bring the 4 up. Then on the left-hand side, we have a log to the base 3. Combining these together, it is going to be x squared multiplied by x plus 2. This will be log to the base 3 of 3 to the power of 4. So what we can now do is we can compare what is within this log to the base 3. On the left-hand side here, we have x squared, x plus 2. And on the right-hand side here, it's going to be 3 to the power of 4, which is going to be equal to 81. So expanding this, we have x to the power of 3, then plus 2x squared. Bring it to the left-hand side, minus 81 is equal to 0. And there we have it. This is a cubic equation in x. Question number 13. So in question number 13a, we have a spherical balloon. It is being inflated at a constant rate of 500 cm cube per second, and this balloon is initially empty. In part 1, we are supposed to find the radius of the balloon after 1 minute. So after 1 minute, 1 minute is 60 seconds, and this balloon is expanding at a constant rate of 500 cm cube, and initially it is empty, which means that after 1 minute, which is 60 seconds, the volume, I'm going to let it be V, is going to be equal to 500 multiplied by, not 1 minute, but 60 seconds. So this is equal to 30,000. And what is the volume's formula? It is actually given to us by the question. The volume of a sphere, which we are going to assume that the balloon is a sphere. So this is going to be 4 over 3 pi r cube. This is going to be equal to 30,000. If I were to make r cube the subject, r cube is going to be equal to 22500 over pi, which means that r is going to be the cube root of 22500 over pi. If I were to press this into the calculator to 3 significant figure, r is equal to 19.3. And in part 2, let me write it down here. In part 2, we are supposed to find the rate of the radius of the balloon after 1 minute. So we already know what is the radius. After 1 minute, the radius is equal to this, or 19.3. 1 minute later, if I were to try to find the rate of change of the radius of the balloon, I'm going to start by looking at the volume. Volume, which is equal to 4 over 3 pi r cube. I'm going to make use of this to generate for myself the rate of change equation. So from here, I'm going to find dV dr first. So it's going to be 4 over 3 pi multiplied by 3r squared. So dV dr is equal to 4 pi r squared. So after 1 minute, after 1 minute, dV dt is still equal to 500. This is what that is given to us by the question. It is a constant rate of 500 cm cube per second. After 1 minute, we know the radius is equal to the cube root of 22500 divided by pi. And if I were to quote the rate of change equation, it will involve dV dr also. Let's find the value of dV dr first. dV dr is going to be equal to 4 pi r cube, 4 pi r squared. So it's going to be the cube root of 22500 over pi, this square. And now I'm going to quote the rate of change equation, which is dV dt is equal to dV dr multiplied by dr dt. And this is what we are supposed to be finding. dV dt is equal to 500. Is equal to dV dr is this, 4 pi, then the cube root of 22500 over pi square multiplied by dr dt. And this is how we're going to find dr dt. It is going to be 500 divided by this, which will be giving us a 0.107. There is still going to be a part B. Let me erase this so that I can do part B. 13b, we have this weather balloon, and we are given this equation which involves pressure and volume. It is going to be equal to K. This K is a constant. What we are supposed to do is to find the rate at which V is changing with respect to P. And I think this is not the most familiar kind of phrase to see in a rate of change question, but this sentence here, find the rate at which V is changing with respect to P, is actually trying to ask us, based on this equation, right? Can we find the rate of change of V with respect to P? The question is asking us to find dV dP. So let's try to do that by making V the subject. V is going to be equal to K divided by P, which I can write it as P to the power of -1, which means that dV dP is going to be K of minus P to the power of -2, which is going to be K minus K over P square. And what is K? K is PV. So I can actually simplify this by replacing K by PV divided by P square. So if I were to cancel this, this is just simply going to be equal to minus V over P. So dV dP, which is what the question is asking us for, is minus V over P. And we're supposed to find this when, according to the question, this is when V is equal to 2. So when the V is equal to 2, the question also told us that P is equal to 1.2. Therefore, we can find the rate at which V is changing with respect to P, which is dV dP, is minus V, which is 2, divided by P, which is 1.2. So this is equal to minus 5 over 3. Okay, the last question, question number 14. So in question number 14, we are given this, and we are supposed to, in part A, find the coordinates of this point Q. So for point Q, it is lying on the normal, and that is also the point where the normal to the curve is going to be intersecting the x-axis. So the first thing that I want to do is to try to find the equation of this line, okay, the equation of the normal. So to do that, I'm going to make use of differentiation. I'm given that y is equal to 4 plus 3x to the power of half. I'm going to find dy dx, and that will be half 4 plus 3x to the power of minus half. Differentiating this again by chain rule, this is going to be equal to 3. So this is going to be equal to 3 over 2 square root of 4 plus 3x. So this is dy dx, and we are supposed to find the gradient of this line, which is the normal. So I'm going to first work on the gradient of the tangent at this point P. So at the point P, 4, 4, the gradient of the tangent, which is dy dx, is going to be equal to 3 over 2 square root of 4 plus 3 times x is equal to 4. So this is equal to 3 over 8, which means that the gradient of this line is going to be negative 1 over 3 over 8, which is negative 8 over 3. So this will give us the equation of the normal at the point P, which is going to be y minus away the y coordinate of a point that is lying on this line. I'm going to use the point 4, 4, is equal to the gradient of this line, which is minus 1 over this, which is minus 8 over 3. And x minus away the x coordinate of a point, that same point that is on this line, which is based on P, so it is 4. So this, I will be getting a y is equal to minus 8 over 3x plus 44 over 3. And at point Q, that is when the y coordinate is equal to 0. So at point Q, I'm going to let y be equal to 0, which means that minus 8 over 3x plus 44 over 3, this is equal to 0. This tells me that x is going to be equal to 11 over 2. Therefore, we know what is the coordinates of Q. The x coordinate is 11 over 2. The y coordinate is 0. And based on this, I guess we are going to try to work on part B, which is to find the area of the shaded region. So it is this entire region over here. So for part B, I'm going to make use of definitely the coordinates of Q that we have found in the previous part. And that is 11 over 2, 0. So to work on this, the area of this, I'm going to try to break this area into two parts. So starting from 0 all the way until this point here, let me draw a vertical line down. Okay, so for this line, the x coordinate is 4. So I'm going to first find this area, then I'll add to this area, which will then give me the area that the question wants, the area of the shaded region. So for this area over here, I'm going to make use of integration. So I'm going to integrate from 0 to 4 for this curve, which has this equation. So it will be 4 plus 3x to the power of half. Then plus this area. What is this? This is a triangle. So half times base times height. Half times base. Base is 11 over 2 minus away 4. So 11 over 2 minus 4 multiplied by the height, which is the y-coordinate of point P. So height is going to be equal to 4. Integrating this, we have a 4 plus 3x to the power of half plus 1. This is 3 over 2 divided by the coefficient of x, which is 3, then 3 over 2. This is going to be from 0 to 4. This is going to be plus this. This is going to be equal to 3. So this will be 9 over 2. If I were to bring it out and flipping it, we will have a 2 over 9. Then let's substitute this, the upper limit, into here, which will give me a 4 plus 3 times 4, 12 to the power of 3 over 2. Minus away, substituting 0 in, it is going to be 4 plus 0. So it's just going to be 4 to the power of 3 over 2 plus 3. And this will work out to be a 139 over 9.